G'day team, welcome back to another video on apps of integration and kinematics part 2. It's only a small video today, just a little extra thing to add on from the last video, but I thought I'd split it up nicely just so it's not too overwhelming. So we saw that v of t equals the integral of a of t dt. All right, so we've sort of seen that, talked about it. But there's this nice handy flow chart that's been created here to show what to do when you want to move from one function to another. So if I want to go from left to right, I need to differentiate. And if I want to move from right to left, I have to integrate and keep in mind my constant of integration. Now, if we are given extra information, we can find that constant. And we're going to look at an example of that now. So I've got v of t equals 32 plus 4t meters per second. Part A, if the displacement equals 16 at t equals 0, find the displacement function. Part B, explain why the displacement and distance can both be represented by the definite integral 0 to t1 of 32 plus 4t dt. Show the object is traveling with constant acceleration. All right, so let's start by finding the displacement function. Now, s of t, we know is the integral of v of t dt. So that's equal to the integral of 32 plus 4t dt. Now that there, s of t is equal to 32t plus 2t squared plus c. But we are told at t equals 0, s equals 16. So 16 equals 32 times 0 plus 2 times 0 squared plus c. So 16 equals c, which means my final displacement function is 32t plus 2t squared plus 16. Now, typically we would write the 2t squared first, but it doesn't matter that much. Okay, explain why the displacement and distance can be represented by the definite integral 0 to t1, 32 plus 4t dt. Now, the big difference between distance and displacement is we have to account for negative distance or away from the origin in displacement. Now, if I graph 32 plus 4t, for t greater than 0, v of t is always greater than or equal to 0. So it's always positive, which means there's no negative distance to account for or negative displacement to account for. So it's always going to be positive, and that's why we can represent them both as the same integral. Now show the object is traveling with constant acceleration. Well, a of t equals v of t, v dash of t, which is the derivative, so which is equal to 4 meters per second squared, and that's a constant, so that's constant acceleration. Now that's a very basic example, but it does give you a bit of an idea of what to expect coming up. So thank you for watching, and we'll catch you in the next video.